Hi, welcome to the pre-calculus lecture series. In this video, we're going to start to talk about section 2.3, getting information from the graph of a function. And from the previous two sections, we start out with section 2.1, right? So the 2.1, we start off to give the basic definition of a function. Then we took a look and find, what is the domain, the range of the functions, how to find them. Then we go over to the section 2.2. So 2.2, basically, we'll just start off giving you the ideas of some very commonly used functions in algebra 2. So like in the pre-calculus, so we talk about the absolute value function, power function, and the roots functions and like reciprocal functions. So the section 2.2 basically just give us the, say, hey, this is what the functions, this type of the function, the graph of this type of function looks like. And then for the section 2.3, this will be a pretty easy section here. So basically is I say, hey, if you see a graph of the function, then what type of the information you can get out from the graph of the function? All right, so how do I find the domain? How do I find the ranges here, right? And how do I find increasing, decreasing here? Then we're also going to introduce a pretty important concept. We call it local max and local mean by looking at the graph here. Okay, so now let's go to our worksheets. Okay, so this is a section 2.3. Is the main things here we want to do is how to get information from the graph of the function. So the first things here, we're going to see how do I identify the range here, right? So here we say the domain and the range of a function f of x, right? And we can obtain from a graph of the function. Okay, so let's take a look at what do I mean here. So this is what I mean. So if this is your graph here, so let me see my function. Let me see here, this will be, right? So this will be my functions here. And then I will say this functions here. So from this function, I look in the graph here, right? So what is the domain? Domain is the value of x, right? So the x start here and end here, correct? So this area, so this lines here from here to here, this is what we say is the what? Is the domains here. Then the range is here. Range is the y value. Okay, so you need to look what is the smallest y value, what is the largest y value here, because they do stop here. So you know the y value start here. So the range doesn't stop here because range is the largest y value to cover the whole range of the y. So here, right? So here is the ranges here. So let's, it's from here to here, right? So that's what we say. This is the range of the y's here, correct? All right. So that's why we say the domain from the graph you can see is from here to here, right? And the ranges here will be what? Will be from here to here. That will be the range. So for example, like if you take a look, if I have another graph here, right? So if I have, this is my graph here. So I will say here, this is quadratic, right? So if this is the graph, and then I know in here, right, my x can continue going. So here, the whole real number line, so this one will be my domains here, right? But then take a look, the range is here, right? So the range is here, that means the y area. So y will never exceed here, right? But y can go to the negative infinity. So this way go all the way down, right? So this way go all the way down. This is what? This is my range here. Got it? So when you look at the graph here, you can identify the range and the domain. So let's take a look at the first examples here. So let's say using a graphing calculator to draw the graph of f of x equal to the 4 minus x squared, then define the domain and the ranges here. So if you go to use the graphing calculator, I'm going to show you here. And so let me get out of here and I'm going to show you a software I like to use, and it's free. And that will be the decimal, where that goes here. And I can, okay, so so let's go back to here. All right, so, okay, let me look again. So here, let me see the cost. Okay, so, oh, here. I should have, okay, so here. All right, I find it. Okay, so this is the decimals, and I think the decimals is a very good, very good graphing tools here. So like right now, I'm going to graph y equal to the square root, right? So you say the square root of 4 minus x to the square, okay? So as you can see, this is what the graph will looks like. So like in here, right? So this is x range is here from -2 to 2. Then the y is from 0 to 2 here. So let's go back to our worksheets here. All right. So now in here, like we just graphed it, right? So we just graphed it. So this is what is the graph going to looks like, right? So this is 2, and this is -2, and this is 2 here, right? So because of this, just like we say, so what is the domains here? So domain is the x values, right? So the domains here will just be from where to where, from the -2 to the +2. Then the range is here, right? So the range is just the y values here, right? So y value is from where to where? It's 0 to 2, right? So here, let's color coding that. So this is my domain, right? So, and this is my range. Okay, so here this is 2, right? So so you can get this graph from the decimal. Let's say by the graphing calculator. Of course, if you have a TI-84, you can do that also. But I find out that the decimals is way easier than the TI-84 to operate here. Okay, so the next thing here, we're going to talk about how do I compare the function values solving equations here. Okay, and so let's take a look at what that means here. So it means that the solution, okay, the solution of the equations f of x equal to the gx, okay, so are the values where the gx and f of x intersect, right? Okay, so the solution, okay, so then the same one, the solution of the inequality. So if I have f of x less than gx, how do I find the solution? Those are the values, okay, of x where the graph of G is higher than the f of x. So this is kind of like the pretty straightforward definition. So from the graph, see here. So let's see here, right? So the first thing is here, I have a first graph here. So for example, I have, so this is my f of x, all right? So the blue one is my f of x. And then the green one, let's say here, this one's here, this is my gx here. So if I want to find the solution here, right? So the solution, okay, so in here, so here's the keyword, the solution of the equations. That means is where they intersect. So the solutions here, I know they intersect here and here, right? So this one's here, say is it A, and this one is B. So the solutions here will be what? The solution will be, right? So this will be the solution x equal to A and x equal to B, right? That's what we mean the solutions here. So now if you have f of x less than gx, so what's that means here? So from the graph, you can see here, right? So I'm still using the f of x. Here is the blue one. So here, this is my f of x. And then I'm using the gx is here, all right? So this is gx here. Okay, so now let's say the inequality. So when you say is inequality is less than, what's that means here? That means you just look, the areas, right? So here, okay, so this one's here, this is A, this is B, right? So you're just looking for the area where the f of x is less than gx, right? So I know in this areas here, this area, right? Because for this area here, the gx is always on top of the f of x. So that means this is the solution for the inequality of what? F of x less than gx. So the way we will write it, we say the solution here will be what? From the A to B. And I use the parentheses. I used open parentheses here. The reason why I use the open parentheses is because they don't have a what? For this inequality, it does not have an equal sign. So that's why I use the open parentheses here, right? Okay, so now let's take a look at these examples here. So let's say solve the inequality graph, by using the graph here, okay? So basically what you need to do is here, then you go to the, you go to your graphing, the calculator, and then you try to see where these two intersect, right? Okay, so now let's go to the decimals again, and let's take a look at how do we solve this. All right, so let me stop the sharing these worksheets, and I'm going to the decimals here, right? Okay, so the first one's here, I need to give a new function. So y is equal to the 2x squared plus 3, correct? So this is the blue one is mine. So I'm adding a 1 is y equal to the 5x plus 6. Okay, so I have a 5x plus 6 here. So as you can see, if I want to solve the equation, remember the solve is what? Is the intersect, right? So the intersect here is negative 0.5 and 3.5 here. If you want to kind of make this a little smaller, you can see like that. And then you want to see the points here, right? So you just go like that. So this is negative 5.3.5. And then, do they have another intersection? Oh, yes. So here, right? So another intersection is 3 and 21. So you know the x solution for here is the -5 and x equal to 3. And then, you will see the line here, right? The line here is above the green line is above the blue line. So that means it's greater than here, right? Okay, so now let's go back to the worksheets and we be able to try to write down the solutions here, right? So as, so like if you want, you can kind of, you don't really, so you can just copy paste the graph here. Okay. Okay, so, or, we already see that on the decimals here. So kind of basically something like this. And then you have, okay, so here, right? So we say the intersection point, this is a -1/2 and 7/2. And what is here? You still remember? This is 3 and 21, right? So here. Okay, so now let's take a look. So what is the solution for the equal? Remember, the equal is the intersections, right? So that means x is equal to what? -1/2 and x equal to what? X equal to 3, right? Okay, so now the next ones here, they say the 2x squared plus 3, that means this parabola is less than the line. So where is the parabola less than the line? It's here, correct? So this is a parabola less than the line. And because it does have the equal sign, so what is I need to write here? So I know the solutions here. Because in this yellow regions here, the parabola is below this linear function. So I know the intervals here will be what? It's -1/2 to where? To 3, right? So let's hear, this is 1, -1/2, this is 3, right? The reason why I use, so here this bracket. The reason why I use bracket is because these ones have an equal sign. Okay, so the same way, let's take a look. Where is the parabola greater than, right? So the parabola greater than, that means the parabola is above the line. So it will be here and here. All right, so what is our solutions here? And because it does not have an equal sign, so let's try to write the solution. So this line here, this purple one, is from the -infinity all the way to what? To the -1/2, right? And the union from the 3 to what? To positive infinity. You get that? All right. Okay, so that is how do you find solve the graphically, right? So you solve the equations, solve the inequalities here. Okay, the next things here we're going to talk about is the how do I identify increasing and decreasing? Okay, so we said f of, this is also very intuitively is true. So if f of is increasing, okay, on an interval, okay, I, if f of x1 less than f of x2, okay, whenever, right, so whenever x1 is less than x2 in I, that means anytime you choose the two values in this interval, then the x1 always has to be less than x2 if this is the increasing function. And the f is decreasing on an interval. I should say here. Okay, so here on the interval, so I should say on intervals here. All right, on an interval. All right, I, the same thing. If decreasing, that means x1 is greater than f of x2. right? So it's the same thing. So whenever x1 is less than x2 in I, okay, so now if you take a look at the graph, it really is pretty straightforward, right? So here, let's take a look at this is my function here, all right? So this function, let's say here, this one's here, this is my f of x function. Okay, so take a look here. So for these functions here, right? So if I have this number, this is x1, this is what? x2. So what is this ones here? This is what? This is my f of x1, and this what is here? F of x2, see here. So as you can see, when x2 greater than x1, this function is what? This function is continuous going up, right? So that's why we say this is increasing functions here. Okay, so now let's take a look. So like for the decreasing function here, right? So let's see here, I mean, give you example here. So here, this is my f of x here. This is the f of x. And the same way, if you have 2 points, so this one's here is x1, this one's here is x2. So the same way, the x1, x2, so this point is f of x1, right? So this point is f of x2. So as you can see, the x2 greater than x1, but the f of x2 is less than f of x1. So by the graph, so you can see kind of a very obvious. So this is going down, right? So, you know, when we say going up or going down, it's always from the left to the right. Okay, so we make sure we do that. Okay, so now the next one's here. I said a sketch a graph of the function 12x squared plus 4x3 minus 3x4 here, right? Then I want to find the domain and the range. Then we also want to know where is increasing and decreasing here. Okay, so let's stop here and then let's go to our famous, you know, the decimals, and I really like this software. Yes, okay, so let's try to type in our function is 12x squared plus 4x cubed minus 3x fourth. Oops, x fourth, right? Okay, so this is, okay, so this is the graph I'm going to have, right? So like in here, so the first things here, they say the domain and the range. Okay, because the x is continuous, right? So the domain will be everything on the x-axis, even like this one, say if you get close, smaller, right? So, but the axis can go to the infinity and the negative infinities, right? Okay, so now let's get it bigger so I can see the details here. So the domain is going to be the infinity, negative infinity to the positive infinity. Okay, now let's take a look at the range. I know the y value goes to the negative infinity, but the y value have a top. Oh yes, the y value have a top here. So it's 32 here, right? So that's why I know the y values here has a top here. So the range is here is from what? It's 32 to the negative infinities, right? Okay, so they also ask us is what is the interval of increasing or decreasing? Okay, so now let's take a look here. All right, so increasing is from here all the way to what? To here, right? So the increasing is from negative infinity to negative ones, right? So after that here, oh, boom, I decrease, right? So the decrease is from where to where? Is from -1 to where? To zeros, right? And then you go all the way up again. So it's increasing, and I know the increasing all the way to what value of x? True, right? So it's true, right? So it's 0 to 2. Then after 2, what happens here? It's decreasing here. It's go boom, right? So it's decreasing. So what is going to be? So decreasing will be 2 to the what? To the infinities here. All right, so that what is the graph going to looks like? And now let's go back to our worksheets. So make sure we capture and here, all right? Okay, so now let's take a look here, right? So let's see here. And since we already sketched it, so let's kind of just do a sketch what we learned here, right? So here we say here, okay, so we say here, and okay, of course, you know, if you want to see the detail, you go there. Okay, so, you know, go to the decimal, you can see the detail. Okay, so let's see the domain here, right? So the domain, the x value, so what is here? From the negative infinity to the positive infinity. And the range here, the range is the y values here, right? So the y, we know that this point a while ago, this is 232s, right? Okay, so the range, the y value, the largest value of the y can be is 32. Then the smallest value, because look at these two tails, they go into the infinity, negative infinity. So what is the range of here? So it's from the negative infinity to where? 32. And this 32 is what? It's a bracket, right? Because it does include the 32. Okay, so now they want to find the interval. F of x is increasing. Okay, so now we know this part is increasing here, right? So we say, hey, this is increasing, and we know increasing here, right? Okay, so now let's try to write our solution. So we know increasing. All right, so the increasing is from what? Axis could be from negative infinity because it's from all the way to here and all the way to where? To the -1, right? And what is the x can be increasing from the what? This part is what? This is the, let's try to write here. So this is -1, this is 2, and this is 0, right? So now what is the increasing again? From the 0 to 2. Okay, so the same way, let's take a look of where is the function decreasing. Okay, so the decreasing here, you boom, 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 going down, right? And this is a boom, 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 going down here. So I know the decreasing is what? Okay, so the decreasing is -1 to 0. And what is here? 2 to what? 2 to infinity here. All right. Okay, so that's it. That's a pretty, you know, easy, you know, as soon as you have the, you know, the graphing tool help you, then that's good. Okay, so the next ones here we're going to talk about is a very important concept. We call it is the local max and the local mean. And in pre-cal, we're going to just take a look at what is the meaning of the local max and the local mean. But when you go to the calculus, when you go to the calculus 1, they will ask you to find the local max and the local mean. So here, all right? So, okay, so let's take a look at what is the local max. We say the functions here. The function value, f of a, is the local max. Okay, if f of a greater than or equal to f of x, where x is near a. Gee, what's that mean? Okay, so this is the number 1. That is the local max here. So the local mean is the same thing. So the function value of f of a is local mean. Then if That means f of a is less than f of x, where x is near a. Whoa, let's see, what is that means here, right? Okay, so let me try to graph it because we are trying to solve this by graph anyway. So let's try to graph it and then let's take a look at what that means here. So if I have a function go like this, okay? All right, so if this is my f of x function, so this is what we mean is the local. That means around it. So first things here, let's take a look at this point here, right? So let's take a look at this point. If this point, x equal to a, this point, let's say this is b, and this one is c, and this one is d. Okay, so as you see here, right? So this one's here, this is f of a. So when I mean the local, right? So that means if you take a look, this is at the top of the mountain, right? So if you look around, right? So in a close area, so like in this neighborhood, if you look around, this is the highest point. But this is not the highest point for the whole function because this function goes to the infinity, right? So that's why we said f of a, what is here is a local, what is a local max, right? So let me say at x equal to a. So when the x equal to a is a local max, that means at this moment in a close ranges here, this is the highest point. So the same way, take a look at these ones here, right? This is what? This is f of the c. Obviously, f of the c is lower than f of the a. But by this point, this c is here, still at the top of the mountain. So this is another local point. So I know the f of the c also is what? Is local max here, just by compare to its neighbor. Here, this one's here, right? So this one's still at the top of the mountains here. So that's why this is the, is the local max. So we will say f of c is local max at x equal to c. So now let's take a look here. So like the b here, right? So the b here, hey, for the b here, if you look around, what happens here? What happened to the b here? This is the valley. This is at the bottom, right? So this is at the bottom of this valley. So at the b here, this is the smallest value around this neighborhood, right? So I know f of the b is what? Is a local minima. Maybe it's not the minima for the whole function because this function go to negative infinity, but it's local. Just around this small area is local. So add the x equal to b. So the same things here, right? So for this ones here, this is f of the d. F of the d is, is larger than f of the b. But if you compare just across, very close to a small neighborhood here, the d still is what? At the bottom. So I know the f of the d is a local what? It's also is a local mean at the x equal to what? X equal to d. Cool? Okay, so that's it, right? So let's see what, so basically the local max and the local mean is your turning points, right? So that's why it's like in here, you start increasing. Now, after you hit the top, you start decreasing. Boom, when you hit the bottom, then you're going up again. So the local max and the local mean basically is the turning point about your function here. Cool? Okay, so now let's take a look at this graph, x cubed minus ax plus 1. So let's go to our decimals again so we can see the values here, right? Okay, so here's our decimals. Let's get rid of this function. So let's type in. So this is x to the cube minus ax plus 1. All right. So remember, right? So they want to find the local max and the local mins here, right? Okay, so take a look here. Remember, it's the turning point. Okay, so here is a turning point, right? So x equal to negative 1.633, right? And y is 9.709. So I know this is a turning point. This is a local max or local mean. This has to be local what is max because this point is at the top of the mountain. Then you're going down here. See here, this is 1.633. So this is what? This will be the local mean here. That's another thing here. You know, if you use the decimals graphing, they will give you those important points here. All right, so that's why you know this is local max, this is local mean here. Okay, so now let's go back to our worksheets and we can finish our worksheets here. Okay, so this is our lecture notes here. All right, so now in here, okay, so we already did that. So that's kind of a sketch what the graph looks like. All right, so from the decimals here, you will have something like this. And so we know that we just checked from the decimal. So what is this point here? This is negative 1.633. And what is the y value? See here, 9.709. Okay. Okay, so the way you write it, right? So this is, so we know this is because it's around this neighbor, this is the largest one. So we know the local max is equal to 9.709 at x equal to negative 1.633. Also from the decimals, we find this point, right? So this point from decimal tells us this is 1.633. And so the y value is negative 7.709, right? So that's how do we write it. So we'll say this is local mean is equal to the negative 7.709 at what? At x equal to 1.633. So that's it. That is this write a better word, better writing here, right? So that's it. That is this sections here, how to identify those few key important informations, right? So the most important here, we need to know what is the local max and local mean, you know, that represent. That means at that point, that is the largest number at that neighbors, like a near neighborhood, right? So it's a typical, it will be the turning points here, right? So what is the other things we learn here? We learn is where it's increasing and what is the decreasing, right? So what is that means here? And also we see from the graph, how do we do, the domain and the ranges here. All right, like I said, this is a pretty simple ones here. So it's nice to talk to you. And have a good day, and looking forward to talk to you in the section 2.4 here. Okay, bye. Have a good day.